Welcome back to another video, and this time we're gonna do a bit of Go again because I do like learning new stuff, and I think I know C a little bit, not good at it. Python I'm a little bit moderate at it. I thought why not just learn Go, because why master one language when you can be just a little bit good in three languages. So I think what we'll be doing is we'll just be doing learning Go fundamentals with learn Go with tests. I have been doing this, right? I did pointers and errors for the last one, right? And this one went over how we use pointers and stuff like that. And yeah, then we learned that. So but I'm gonna finish this first. So what we learned yesterday, um if I'm correct, we learned about methods and functions. So normally when you have a func in this, you can say func EBS. We have a func. Let's say we have a normal func in this. This takes v vertex and let's say returns 464. Like this is gonna be something, right? But then you can do something like, you can also do something like func v vertex, and then you can say, well, this is a method and this returns 464. And you could also do this as v or v star, doesn't really matter. You can put it by value or by pointer. People say use pointer because if you do one value, it's making a copy of it, but with a pointer you can just access. Okay, yeah, if you want to make some changes to it, then that's the case, right? If you were to do that, and then we have interface, to be honest, and I think interface would properly be learned it from here. We had, so as you can see over here, this is a method which is attached to a type of struct which is called rectangle and does that, and we have an interface which pretty much categorizes to all that. Also, one more thing, in Go, interfaces are implicit. You don't have to explicitly say key this is implementing an interface shape. It does it automatically. Go just checks it for you and sees, oh well, this has that function prototype that we need, and so well, yeah, this is an interface. This is a type shape interface, right? um I'm thinking right now of maybe, to be honest, like, let's not do this now. I'm thinking of doing maybe maps. So we'll do that first, and you'll see my workflow around this as well. So yeah, okay, in arrays and slices we saw how to store values in order. Now we look into where to store by items and look them up quickly. So we have a directory test, and we'll call this maps, and we'll call this directory test.co. Normally I just copy paste the code, to be honest, like, and then I start reading the code. Okay, let's see. So we have a package main, so this is going to be run as executable. Imports testing. It does func test, which the function is test search, and we take in a variable t of the type testing.t, and we show dictionary of, okay, the map string to string test. This is just a test, and we say cort, which is search dictionary for the word test. Want, this is just a test. Okay, cool. Maps allow you to store items in a manner similar to a dictionary. It's weird how it says a manner similar to a dictionary. You can think of the key as a word and the value as a definition, and what better way is there to learn about maps than to build our own dictionary? First, assuming we already have some words with the definition dictionary, if we search for a word, it should return the definition of it. So we have a dictionary map, which essentially is a map that has value, key as a value, key as the string, and value as a string. And we want to write a search function that takes in of a map of string to string, and then value test, I would say, something like that. Um, right, so I would do something. What's I think there's some ad happening in the background. Okay, that's crazy. Like, why is there an ad happening? Yeah, so this is what we have there. So we'll say package main, and we'll say func main app, sorry, and we'll do just to hello world. Um, right, and we have this, and if my terminal opens up, I can go maps, and I can do go run dictionary.go, and say that word. Now I can create a func called func search. We call it ticked map string to string, and then value, which is string, and this returns a string, and that's it. And then I can return something of the line of hello. Let's remove this. So that for some reason that's not how Go likes it. I don't know why Go did that. God knows. But yeah, so this is the reason. This is how Go does it, which is weird. But yeah, so we say a dict of that, and we take a value, and we take a key actually. Right, we take a key. So we say something like key, and we just return. I think that should work. So now if I do go test, I think that's the syntax if I'm correct. I have forgotten a bit of Go though. So also Go takes it goes very fast. So it does fast. That's great. Hey, so if we were to have more, this is second test. This is another test. Right. So this is another test that we're doing. Okay. So that is what pretty much. Um, Declaring a map is somewhat similar to an array, except it shares the map keyword and requires two types. The first is the key type, right? So over here, again, over here, we have a map, right? First thing is the key type, and requires the first is the key type, and which is written inside the brackets, and the second is the value type, which is goes right after the bracket. The key type is special. It can only be a comparable type without the ability to tell if two keys. The key type is special. It can only be a comparable type because without the ability to tell if two keys are equal, we are not to ensure that we to. Okay. Okay. The value type on the other hand can be so we can compare it. So this is essentially just so we have the t function. It's just a helper function, right? Nothing much. And then we can come here and say assert string, and I can pass in t god want and run go test again without worrying about other stuff. So it basically takes in the same object, but interestingly, this one takes a pointer, this one takes the value. Interesting. Um, Using a custom type, we can improve our dictionary's usage by creating a new type around map and make search a method. So what exactly is happening over here is instead of the user writing this, which is kind of clumsome, um, okay, instead of this writing this, we could have a type def. So we could say something like type map string is of dictionary, and I can do this rt. But that is amazing and that works. And there's an issue over here. What is the issue? Expected. Okay. Okay, it's before that. My bad. It's before that. So we have this, right? And so now I can say something like doing instead of doing this, we can say dictionary, right? And then we can have a search on the dictionary. So we can change this a little bit. We can say func, and we can say d dictionary, and we can say search, and we take the key value and we return a string, and then we say t dot key, and also that key will have a value of string itself. What's the issue? My bad. Return. Right. So now this will work, because now instead of doing this, I can say got um, um, dot search. What am I doing? I can say got is equal to, first of all, before this, let me just do that. And I can do dictionary dot search, and I can say test, and this will work because I've essentially just created a dictionary type out of the map type. Nothing so nice. And then I just call this method on this. Takes a while, chat, doesn't it? Like, okay, well, while this is taking some time, what is this? Maybe about 4 seconds क्यों लगा इसको? Something is going wrong. It shouldn't take this long to write code outside. Like, something is going wrong. Anyhow, write the test first. The basic search was very easy to implement, but what will happen if we supply the word that's not in our dictionary? We actually get nothing back. This is good because the program can continue to run, but there is a better approach. The function can report that the word is not in the dictionary. This way, the user isn't left wondering if the word doesn't exist or if there's no definition. This might not seem very useful for dictionary. However, in this, it's a scenario that could be a key in other use case. That's actually much better. So we say t dot run known word func, and this is pretty much anonymous functions call. So we say got slash want, and I think this is about whether it's there or not. Um, I think, I don't know. Let me check. So we will essentially just copy this and chat this thing. Okay, buddy. I don't want to listen to ads. I think I've made that clear. So don't want to listen to ads, chat. Um, yeah, it returns only one. And the thing is, this will now return error, which is error. Um, with an error type, yes. So this is way too loud, chat. Yeah, so return a second with an error type. Notice that we have seen the pointers the hint in order to assert the error statement. We first check that the error is not null and then use dot error method to get the string which can be passed. This does not compile the right way. So yeah, we pretty much, wow. Okay, we're not taking intent error. My bad, that was bad. We return an error and we will return a string and an error, and we return this. And normally, yeah, so over here we return nil, right? It's the equivalent of null over here, and you see this works, right? Thing why it says that this is unknown. Like, the thing is, this test here is unknown word and error. If error is equal to none, right? So if I run go test now, this will pass, right? This will pass. Yeah, so it's expected to get an error, but we didn't get an error. So this is happening, right? So yeah, okay, I knew this would be the case. Righty. So first of all, we would do something like value and okay is equal to t key, something like that. And if okay, else. So what exactly is happening is we will return value slash nil, and we will just do, sorry, my bad, value, and else we will just return nothing. And I think, how do we return an error? Okay, we say errors dot new, okay, errors dot new, and we say could not find the word you were looking for. Okay, so that's working. And wow, that you want this exact same thing to be there, which is sad. um, okay chat, let's see if this works. Let's remove that. This should, so this is how we declare, this is how we declare an error, errors dot new, and then this will say cool. If in order to make this pass, you're using an interesting property of the map lookup, it can return two values. The second value is a boolean which indicates if the key was found successfully. This property allows us to differentiate between a word that doesn't exist and a word that doesn't have a definition. Refactor. Ah, okay, so I could just pretty much come here and on top of my just define all the errors that we want to look for, like how we do in Java. Um, I think you can't do that. Like if I remember very carefully learning about this, you actually can't do that. You actually can't do this. Sorry, you actually can't do this. So you'll see this error expected declarations. You can't do that. Pretty much. Pretty much you can't do that. And instead of doing this, which is again kind of ugly, and you want to do error not found, and so that is much better. And I can run my code test again, and that works. Right, we can get rid of the magic error in the search function by extracting it into a variable. This will also allow us to have, we can get rid of the magic error in our, what do you mean by that? Well, what do you mean by that? um right, I mean, that's kind of true. We can kind of say something like, um yeah, that's even better. We can get rid of the magic error in our search function. What are you doing? Assert got assert error. So I can say assert error, and this will say, well, that doesn't exist. And this is pretty much gonna be of error type, and this will be assert error. And is it something, wait, what do we say? Oh, want is also of an error. Ah, okay, acha, okay. So X pretty much is like want error, right? I guess so now this will just say to us, right? Great. Yeah, so it works also. That is good. Cool. By creating a new helper, we were able to simplify a test and start using error not found variables so our test doesn't fail if we change the error text in the future. Yes, that's great. Yeah, even I didn't like that, hard coding that there, because now this depends on this, right? So that's great. Git status, git, git, my bad, cd git status, git add, learned about maps, and learned about maps, git push. Right, write the test first. We have a great way to search the dictionary. However, we have no way to add new words to our dictionary. So we do test. We run a new test called test add. So this is test search, and now we have a new test that is just test search. Um, so we do something like test search, and we will have dictionary.add. This is just a test. And so I think the way we can do this, if I do something like func d dictionary, method is called add, and what does this give? This gives us a key and a value, so we can have something like key key string value string, right? We are obliged to give nothing, right? So I would assume it's like d key is equal to value. I hope it's that simple. I hope this is just a test. Get.error search test should find added word error assert string, and this asserts it, right? So if I now run go git push for no reason, if I run go actually do cd maps, if I do go test, it passes, great. So oh yeah, also one more thing, word and definition, yeah, that's much better. I think what we can do is, yes, you can say word and word. um, let's change this up. Let's say word slash definition string, definition, what the fuck, definition word. Yes sir, this is actually a convention, right? To write this in small case. Your test now should fail, write enough code. And an interesting property of maps is that you can modify them without passing. An interesting property of maps is that you can modify them without passing as an address to it. Wait, an interesting property of maps is that you can modify them without passing an address to it. A map value is a pointer to a runtime. A map value, so a map का जो value है, so whenever we run map, right, whenever the, so we have, so I think what it's trying to say is we have all of these keys. These are just pointers to some heap allocated value. Okay. Okay, this is getting interesting. So when you pass a map to a function method, you're indeed copying it, but just the pointer part. Yeah, I mean, it's the same thing as saying whenever you're passing a pointer, you're not actually passing the pointer, you're just passing a copy of it, not the underlying data structure that contains the data. A gotcha with maps is that they can be nil value. A nil map behaves like an empty map with reading. When reading, but attempts to write to a nil map will cause a runtime panic. You can read more about maps here. Wow, there's so many things, there's so many blogs. I think reading blog posts are equally important. Also reading documentation as well. So yeah. Therefore, you should never initialize a nil map variable, because reading to them won't be an issue, but writing to them will be an issue. Instead, you can initialize an empty map or use the make keyword to create a map for you. So we can do map this, and this creates an empty map because this creates a nil map. Or you can do make. Both approaches create an empty hash map and point directly at it, which ensures that you will never get a runtime panic. Okay, refactor. There isn't much to refactor in our implementation, but the test could use a little bit of simplification. So over here, we get test add. So change around this word. And oh yeah, we can also do that. So definition. This is just a test, and ft change around this definition. Done. Right. Um, That's like minor refactoring. Set definition. Yeah, so we do assert definition. So this will be somewhere over here. Oh yeah. Yep, so this asserts the definition, which comes over here, and it pretty much runs that and checks for the definition. Same I like in learning Go with tests. There's so much focusing on actually refactoring the code, where in other blocks don't really care about refactoring the code because there the aim is to teach you a concept and just show you how it works. But I think I like this approach because then it's pushing me to understand how refactoring works and like what refactoring means. Right? You just hear the word refactoring, but you don't really know what do you mean by that. Like, what do you mean by refactoring something, right? So we made variables for word and definition and moved the definition assertion into its own helper function. Our add is looking good, except we didn't consider what happens when the value we're trying to add already exists. Map will not throw an error if the value already exists. Instead, it will just go ahead, override the value with the newly provided value. This can be convenient in practice, but makes our function names less than accurate. Add should not modify existing value. It should only add new words to our dictionary. So yeah, that's true, right? If your naming is that, then it's confusing. So we're gonna do that. So again, I will just come here, um, delete this implementation, and this is our right. What's the issue? Add takes a word definition, great, and returns an error. Oh yeah, okay, error. So it returns an error as well, just in case. And I think the way you would do this is something like um, uh, what do you mean? Oh, okay. Right, if okay, that means if it exists, then that's an issue, right? So the if it exists, then we will have to return some error, which I think error would be where uh word present already, or something like that, something like this. But for now I will just add errors dot new word already present in dictionary. Um, else we'll just take this and do this, um, and return nil, obviously, right? So we check if this word exists, then we will return an error, obviously. And what's happening over here? Oh, error word exists. So there's obviously these creators are very proactive and they have created something like that for us to use. We can say var errors dot new, and I don't know. I want to see what they added. Yeah, errors word cannot word because it already exists. Um, I think what we can do is we can say var and remove this, remove this. Let's do that. Right. Um, yeah, and then we can actually just error word exists, and yeah, that's much better, right? It's a bunch of errors. T word definition. Oh, wow. Okay, so T dot search. Oh, we can do that. Does search give us any error? Okay, so I could say something like um, search key, right? Sorry, word, my bad. Um, if error is not equal to nil, because we have to assume for the error key this is not even present. I mean, if it's like if it's not present, that's good, right? Switch error. Okay, I'll use this code. I think this code is important. It introduces a lot of important concepts. Um, so I guess I'll just paste this shamelessly. Switch error. So case error not word form. That's great. We want that, right? Case if it's nil, then we return error word exists. That means it already exists over here. And default, we just return an error. Right? We just return some error. And we return this error, and then nothing. Okay, if error is equal to error, right? If error is, then we want to do keyword is equal to definition and return error. But if that's not the case, um, if it's that's not the case, then we want to do return error word exists. Yeah, I mean this is dumb then. Right, this is dumb because the only error probability is at the error not found or null. So if it's not found, that's great, right? That works. And if we can check our code, you'll see this is a test. Where's the addition? Yeah, test add, right? So definition. Interesting. Other than error not found. I mean, I mean, yeah, I mean, so for now this implementation works, but he has a point. Refactor. We don't have much refactor, but as our error usage goes, we can make a few modifications. Oh yeah, that's great. So we can make them a cons, say cons and dictionary error. Dictionary error. Oh, interesting. So I can say something like type dictionary error, and this could be of string type, and then I pretty much just and I can say something like string. So we don't have too much refactor, but as our usage goes, we can make a few modifications. So we say, okay, so this is of type dictionary error, and func t dictionary error returns an error. Okay, runs an error and returns what? Returns a string. Return. So I'm okay. Uh, I wonder why is this refactoring needed? We made the errors constant. This required us to create our own dictionary error type. Makes it more reusable and immutable. ठीक है. Okay. Same word. And the way our code is structured. Um, okay, let's run our test, I guess. One simple fix would be t dot word equal to new definition. But we would like to make sure um this is a better way of doing this. it's expecting an error. Okay. Yeah, so I guess the simplest way of doing this is something like dot search for that word. If error is error not found, right? Error not found. It's not found, so we will pretty much just say returned does not exist, else will return nil, and we will also do t.word is equal to new definition. Okay, that's fast. We added yet another error test. Cannot perform the operation on what because it does not. It already exists. What does not exist? Does not exist. Not found, right? So मतलब है ही नहीं. Okay. So again, we're writing another test, which is right. This is a delete, so we have to make a delete func. Say func d dictionary delete, and I'm assuming we just taken that here. So we say word string, and we give out nothing, but we wanna give errors out in the future as well, as you see. But yeah. Oh, so we have a function for that. Interesting. So we can just say delete the word. I would assume the next step refactor. This isn't much a refactor, but we can implement the same logic from update to handle cases where the word doesn't exist, right? So we essentially, yeah, I mean, so we're gonna delete a word that exists, but the existing is so right. This can return an error, so to speak. So I guess again we'll do something like this, where we'll search the word. If it's found, then we will do delete the word, and let's run the test, see if it runs. It does run. We made a full CRUD, create, read, update, and delete API for our dictionary. Throughout the process, we learn how to create maps, search for items in maps, add a new map, update, delete, learn how to make errors, how to create errors. Yeah, that was good. Cool. I think we'll do this in the next session.